Hey guys, welcome to my second Unity devlog for this zombie base defense game. So it's been just over 2 weeks since my first video, and today we're going to be covering what I've achieved in those 2 weeks. So as you can see, the character is following some sort of line to the position below the turret where he will proceed to build this turret. Now, the way this movement works is I implemented the A-star pathfinding algorithm. When I click on the ground, you can see the character creates a new path and then proceeds to follow it. So to get this algorithm started, we initialize a grid of nodes. These are visually represented by squares, as you can see on screen. Now, the red squares indicate unwalkable nodes, whereas the gray ones indicate walkable nodes. So a simple way to determine if a node is walkable or not is to keep a reference to the actual 3D world coordinate of this node. What you can then do is do a check sphere at this position to determine if it collides with anything that you do not want to walk over. Now, since we have the ability to build things, obviously we would want this grid to update every time we play something. So how I do this is I essentially initialize a brand new grid and recalculate those hitboxes accordingly. As you can see, the character finds a path. We then build something, and this path is updated as we would want it to be. So the way the walk indicator works is I have a basic red arrow icon that I created in GIMP. I then instantiate a duplicate of this icon at every node in the walkable path. You guys have probably noticed these clouds in the background. So what their intention is to function sort of like a shadow of war. Now, I will take you guys through a basic example of how to create this. So first I initialize a basic plane. We are then going to use an unlit shader to achieve this effect. So under assets, right click and select create, and then shaders and then unlit graph. Give this shader some basic name. We then open the shader editor so that we can begin editing. This cloud effect can be achieved by a simple gradient noise. So what we do is we create a gradient noise node. We then plug that output into the color node. Proceed by saving the asset, and then what we do is we want to create a material to use. So we right click on that shader that we just created and hit create and material. Give that material a name and drag this onto the plane we created. As you can see, this gradient noise works. But of course, this only works in 2 dimensions. So to introduce 3 dimensions, we are going to mess around with the positions of the vertex. So we create a position node, and what we then do is we change the space to object because we want to be editing this object's positions. Now, a mistake I realized is Unity's basic plane only has 4 vertices, so we won't be able to show this noise successfully. So what you go ahead and do is jump into your favorite 3D software, create a primitive plane, and then proceed to subdivide it a whole bunch of times, which will then introduce a whole bunch of vertices. Now to proceed, we create a normal vector node. What we do with this is we plug it into a multiply node. We then also take the gradient noise and plug that into the input of the multiplier. So now we want to add this modified normals map to the original positions of the object. So create an add node and plug in the respective nodes. We then take the output of the addition node and plug that into the vertex positions. If you save your asset and jump back into the scene view, you will see the 3D visual effects. Now, if we want a bit of control over this noise, we can jump back into the shader graph. What we want to do is we want to multiply this noise by some factor. So we create a multiply node and a vector 1. We then right click on this vector 1 and convert it into a property. This will give us access to this value inside the inspector. So give it an appropriate name and assign a default value. What you do then is you plug the output to this multiply into the original add node and then replace the connection. After saving your asset, you can jump back into the scene view. On the right hand panel, you then expand the shader and you have access to the intensity value. Here's a little extra if you are interested in adding color to your valleys and hills. So I added an extra gradient noise just for some extra variation. What you then do is you create a lerp node which lerps between two colors. I also added an extra emission parameter just to control the intensity. As a side note, if you guys do want a more realistic and in-depth cloud simulation, feel free to ask in the comments. Okay, finally moving on. The next thing I would say is noteworthy is the ability to finally equip items from your inventory. So when you hit equip, the character now officially has clothes. Ignoring the clipping you can possibly see, that is just my bad 3D modeling skills. Now a quick overview of how I achieved this. If you jump into Blender, see this is my current character with rigging setup and his animations. Now a very basic way to create an inventory item is you just extrude the chest faces and delete all the other vertices. This will then have the same rigging and also the same animations. You then export this new asset to Unity and drag it into the scene view. What I then did is I added this to an empty game object and proceeded to just add a basic green material to the actual 3D model. Now for the important bit, I proceeded to create a script which essentially maps the armature of the piece of equipment to the armature of the actual character. Now for those of you interested in the code, here it is. As an important note, you can see that this function takes the parameter target. This target is now referring to the actual character that you want the piece of equipment to be mapped to. Also importantly, at line 10 I use a transform.getChild at 0. Thus, to use this code you should carefully add this game object as a child node to that of the character model. Finally, as a little teaser, I am introducing this noise-based system for my zombie movement. So basically how this works is the zombies will be introduced in phases. So originally they'll start off slowly wandering around, and then as your character and your buildings produce noise, such as the generator's noise, the zombies will move more in a directed manner towards the base. I have implemented a grid-based system, so this gives the simulation of localized noise. So say for example you have 3 turrets in close proximity. These zombies would then see this high noise concentration and then move towards that particular point. As a final teaser, I am currently busy implementing a loot-based system. These will be random drops from zombies on death, which will have varying rarity but also varying stats. But more on a later video. Thank you for watching guys, I hope you enjoyed and see you next time.